Newton's third law, action and reaction. When we talk about Newton's third law, we want to review what we mean when we use the word force. A force is a push or a pull. Now, it's important to know that a force is not a thing, but it is part of a mutual action or an interaction. Force is not something an object has, like mass is something that an object has. Force is an interaction between one object and another object. An object may possess the capability of exerting a force on another object, but it cannot possess force as a thing in and of itself. And when we use the word interaction, what we're talking about is a mutual action between one thing and another. Newton's third law. Whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. Or in other words, we've got what we call an action force, and the action force is one of the forces in our interaction. And that'll equal the reaction force, which is the force exerted by the other object in the interaction. So when we talk about Newton's third law, we're saying that two objects are interacting with each other. They're both exerting forces on each other, and those forces are going to be equal and opposite. Neither force can exist without the other. So whenever we talk about forces, they have to come in pairs. So we can kind of summarize Newton's third law by saying, to every action, there is always an equal and opposite reaction. So let's look at a couple of examples. And what we want to do is we want to identify the action-reaction force pairs. So here's our first example. We have a car, and the car is driving along the road, and we've got an action-reaction pair of forces. In this case, what we need to consider is the fact that our tire is interacting with the road, just like the road is interacting with the tire. So the tire and the road are an action-reaction force pair. The action would be the tires pushing on the road. And we know that forces come in pairs, and we know that those force pairs are equal and opposite. So what would our reaction be? The reaction would be the force of the road on the tires in the opposite direction. And what that reaction force will do is it will cause the car to travel forward. So here's another example of an action-reaction force pair. We have a person that's standing on a building and they drop a ball. The action is the earth pulling on the ball, and we know that that force is called the force due to gravity. But what we also have to consider is that the ball is pulling on the earth. So our reaction force would be the ball pulling on the earth. And those two forces, again, are going to be equal and opposite. Now let's look at one last example where equal and opposite forces are not always action-reaction pairs. So let's look at this particular example. So let's look at this example here. We've got a cup sitting on a table. And the first thing we can consider is the interaction between the cup and the earth. The cup is exerting a force on the earth, and the earth is exerting a force on the cup. The second thing we can consider is the interaction between the cup and the table. The cup is exerting a force on the table, and the table is exerting a force on the cup. What we can't say is that the earth is exerting a force on the cup and the table is exerting a force on the cup. Because in this case, you have two different objects that are exerting a force on the cup. We don't have one action-reaction pair. So when we consider action-reaction pairs, what we need to remember is that we identify the reacting objects, which we could just call A and B. And if A is reacting with B, B must also be reacting with A. Just identify interacting objects, and if the action A on B, then there has to be a reaction of B on A.